So in the previous video, what we learned is if you start out with the factored form of a polynomial, you can identify the end behavior, the x-intercepts, the multiplicity of those roots, and the y-intercept. And those pieces of information allow you to draw an approximate graph of that polynomial. We did that several times. It's a pretty complicated section. We did lots of different examples. That was the goal of the previous video. In this video, we want to do almost the same thing. We just want to work backwards. So the goal in this video is not to come up with the graph, but instead you're given the graph and you want to come up with the equation. I think it's easiest to learn this stuff with an example. So suppose you were told that this is a fourth degree polynomial and you wanted the equation of that fourth degree polynomial. The first comment I want to make is to make your life easy, let's just come up with the factored form of the equation of the polynomial. So in your head, you're thinking y equals maybe something with a bunch of different parentheses and some x's in there. How many parentheses should I write? Well, from our fundamental theorem of algebra, each of the roots corresponds with the factor. So since I have a root at -2, a root at -1, and a root at 1, I want 3 different factors here. This root at -2 corresponds with a factor of x plus 2. This root of -1 corresponds with the factor of x plus 1. And this root at +1 corresponds with the factor of x minus 1. And you're like, cool, that's my answer? Well, not quite. It couldn't be your answer because this right here is a third degree polynomial, and it says in the problem that this is a fourth degree polynomial. What are we missing? Well, we haven't incorporated the behavior at each of our different roots. Note that at -1 and at +1, the graph just passes right through those points, but at -2, the graph bounces off. What that tells us is that this multiplicity must be even. Is the power on this factor a 2 or a 4 or a 6 or an 8? Well, you know the sum of the multiplicities must be equal to 4, and we know that the multiplicity here is 1 and the multiplicity here is 1. So this can't be more than 2, otherwise the sum of the multiplicities would be more than 4. The reason it's specified that this is a fourth degree polynomial is because otherwise you wouldn't know to put a 2 here, or a 4 here, or a 6 here, or an 8 here, or whatever. Okay, so now I'm done? Well, not quite. Let's look back up at this last example that we did. 2 times x minus 3 cubed times x minus 1 squared. This factor and this factor manifested itself in terms of the x-intercepts, but if we're just looking at the x-intercepts, we don't get any information about this 2 right here. The point that I'm trying to make is there could be a number out in front here. We don't know. So what we'll want to do is put some constant like the letter a out in front here, and we'll solve for a. And you're like, how are we going to solve for a? Well, one point will always be specified on these graphs. Often it's the y-intercept, but it doesn't have to be the y-intercept. You just look at your graph and find one point that the graph clearly passes through. In this case, it clearly passes through 0, 8. What that means is that when x is equal to 0, y must be equal to 8. So I can come back up here and I can change all my x's into 0s and all my y's into 8, and that'll give me this equation. 8 equals a times 0 plus 2 squared times 0 plus 1 to the first power times 0 minus 1 to the first power. What I have is an equation with only one unknown, the letter a, so I can solve for a. I got 8 equals a times 2 squared times 1 times -1. I got 8 is equal to 4 times -1, or -4a. Divide both sides by -4, and we get that a is equal to -2. What that means is that the factored form of this equation, the answer to this question, is y equals -2 times x plus 2 squared times x plus 1 times x minus 1. If you're not positive if that's right, you could expand this thing. Think about what its unfactored form would look like. I guess it would be y equals -2x to the 4th plus a bunch of stuff, I'm not sure what, plus 8. And then you could say, all right, my y-intercept should be at 8. Sure enough, it is. My x-intercept should be at -2, -1, and +1. Sure enough, they are. The behavior at those different roots should be bouncing off at -2 for this multiplicity of 2 and passing straight through at -1 and +1 for the implied multiplicities of 1 on each of these factors, which is exactly what happens with my graph. You could even check the end behavior from this term, recognizing that when we go to the left, the graph goes down, and when we go to the right, the graph goes down. But really, you don't need to do any of that check. If all you're trying to do is come up with the equation of the factored form of the polynomial, which is all we're trying to do in this video, All you have to do is come up with factors that correspond with each of your different x-intercepts, put an exponent on those factors corresponding with the multiplicity of the different roots, and then recognize that by just looking at the x-intercepts, we don't figure out whether there's a number out in front here. So put an a out in front and use any point on the graph to solve for that value of a. A lot of information, so let's do it a couple more times. Here's another polynomial. It tells me that it's a third degree polynomial. I look at the polynomial and I see that I have an x-intercept at 0, I have an x-intercept at 3, and it looks like it passes through this point 1, -4. So if I want the factored form, I could say y equals x minus 0 times x minus 3. And then I'll think about what the exponent on these factors should be. Over here, it should clearly be equal to 1 because my graph just passes through this point without flattening out. Over here, I know that it's an even multiplicity because my graph bounces off. What even number should it be? Well, it's a third degree polynomial, so the sum of the multiplicities must be 3. This must be a 2 right here. I'm almost done. I just don't know if there's a number out in front, so I'll put an a in that place and I'll solve for a. How do I figure out a? By recognizing that when x is equal to 1, y has to be equal to -4. So -4 must be equal to a times 1 minus 0 to the first power times 1 minus 3 to the second power. -4 must be equal to a times 1 times 4, that 4 being -2 squared. -4 equals 4a, therefore a is equal to -1. So my final answer would be y equals -1 times x minus 0 to the first power times x minus 3 squared, or the way most people would write this is negative for this -1, x for this x minus 0 to the first power times x minus 3 squared. One more example, then we'll call this video good. Here's a 5th degree polynomial. See if you can come up with this equation. What you know about it is it has an x-intercept at -3 here, which has even multiplicity. It has an x-intercept at 0 here, which has multiplicity 1. It has x-intercept at 1 here, which also has even multiplicity. And it passes through the point -1, 32, as indicated by this dot. We know it's a 5th degree polynomial, so that allows us to figure out the multiplicity of these two roots, where right now all we know is the multiplicity is even. In order for the sum of the multiplicities to be 5, since all of the multiplicities are positive numbers, this multiplicity must be 2, and this multiplicity must also be equal to 2. So our equation is y equals some number that we don't yet know times x plus 3 to the second power for this root at -3 with multiplicity 2, times x minus 0 to the first power for this root at 0, times x minus 1 to the second power for this root at +1 with multiplicity 2. Because the graph passes through the point -1, 32, when x is equal to -1, y better be equal to 32. So 32 is equal to a times -1 plus 3 squared times -1 minus 0 to the first times -1 minus 1 squared. A little bit of tedious arithmetic will allow me to solve for a. -1 plus 3 is 2, and 2 squared is 4. -1 minus 0 is -1, and -1 to the first power is -1. -1 minus 1 more is -2, and -2 squared is +4. What I'm saying is 32 is equal to -16a, and therefore a is equal to -2. Now that I know a, I know that the equation of this polynomial is -2 times x plus 3 squared times x minus 0, which I could just write as x to the first power, times x minus 1 squared. This is a perfectly fine answer to leave things this way, but typically what people do is they write all of the factors that don't have parentheses around them at the start. So a more common way you'd see this written is -2x times x plus 3 squared times x minus 1 squared. And that's all I got for this video.